Welcome back, everyone. In this section, we are going to look into another important component of Hyperledger Fabric, which is ordering service. Ordering service, sometimes also called as orderer, and why this ordering service is needed. What is the mechanism behind the ordering service comes into picture. The mechanism by which applications and peers interact with each other to ensure that every peer's ledger is kept consistent with each other is mediated by special nodes called orderers. So there are different types of orderers as you can see here. First one is Solo, second is Kafka, next is Raft. In Solo, you have one single orderer, and in Kafka, you can have a cluster of orderer. And Raft is a newly introduced ordering mechanism which is recommended from version 2.0. The Solo and Kafka is deprecated from version 2.0. So if you are starting with a project, then it is recommended that you have to go with the Raft, which is from version 2.0. Now let us look into the ordering service and how it works and where it stands in a Hyperledger Fabric point of view. So orderer automatically broadcasts messages containing transactions to peers to be committed. All peers receives the same block of transaction in the same order. The ordering service orders transactions on first come first base, which is FIFO mechanism for all channels on the network. After the transaction is ordered, the records are put into a block, meaning the transactions are put into the block for that communication channel. So as you can see from this slide, you can come to a conclusion that orderer is responsible for getting all the transactions and blocking it or bundling it as a block, and the communication takes place from that point. So as we have already seen in from the peer structure, there is a difference between update and query transaction. So when it comes to update transaction, we need to go through a process called consensus. Let us look into that more in detail. An update transaction is quite different from transaction like query transaction because a single peer cannot on its own update the ledger. Updating requires the consent of other peers in the network. So a peer requires other peers in the network to approve a ledger update before it can be applied to peer's local ledger. And this process is called consensus, which takes much longer to complete than a simple query. This means that when you do a query transaction, from any peer, you can get the output, which means the consensus is from all the peers are not required for a query transaction. But when it comes to update transaction, the consensus from all the peers is required, and that is why that the process of that consensus has to happen among all the peers, and this takes more time when compared to a simple query transaction. So, how this consensus happens? So, the consensus happens in three phases. So, these are the three phases that you have to go through for updating the ledger in Fabric. So, this is taken care by orderer itself in Hyperledger Fabric. Now, let us see the phases. In the first phase, applications work with a subset of endorsing peers, each of which provide an endorsement of the proposed ledger update to the application, but do not apply the proposed update to their copy of the ledger. So, in the first phase, what happens? When the application sends a transaction, update transaction to the endorsing peers provides endorsement and proposed ledger update back to the application. At this point of time, the peers do not apply the update to their copy of the ledger. This update happens after the third phase. which we will see next. So in the second phase, these separate endorsements are collected together as transactions and packed into blocks by orderer. In the third and final phase, these blocks are distributed back to every peer where each transaction is validated before being committed to the peer's copy of the ledger. As I told in the first phase, when the proposed ledger update happens from peer to the application, at this point the peers don't update their ledger. In the third phase, when it receives the block and that block is circulated by the orderer, at that time each transaction is validated and later it is committed to the peer's copy of the ledger. These are the phases that has to go through for updating the ledger in Fabric. So the three phases that we have discussed in the last slide, along with the below topics, are covered in depth in our course material, which is orderer nodes and channel configuration, orderer nodes and identity, orderers and transaction flow, orderer service implementation, which is RAFT. We will also see the lab implementation, like what are the channel configuration file and where exactly we need to write the code and all that in the practical section. So in addition to ordering role, orderer also maintains a list of organizations that are allowed to create channels. This list of organization is known as consortium, and the list itself is kept in the configuration of the orderer system channel, also known as ordering system channel. We will look into orderer system channel in practice, which is inside a configuration file. So we will look that in the practical section. So orderer also enforce basic access control for channel, restricting who can read and write data to them, and who can also configure them. Remember that who is authorized to modify a configuration element in a channel is subjected to the policies that are relevant to administrators set when they create the consortium or the channel. So we will look into how we are going to create the consortium and how we are going to create the channel and how we are going to specify the policies and administrators when we actually bring up the network. So this is detailed in the practical section. Now we have, as we have mentioned before, we have Solo, Kafka and Raft. And Solo is mainly for testing purpose where you have only one orderer node. The main competition comes between Raft and Kafka for the production level network. Now let us see which one is better or which one is more supported in Hyperledger Fabric. So Raft is easier to set up. Kafka and Zookeeper are not designed to be run across large networks. Raft is supported natively, which means that users are required to get the requisite images and learn how to use Kafka and Zookeeper on their own. This means that after 2.0, Raft is supported natively. You also get the image of that when you try to download Hyperledger Fabric supported images. So if you want to set up Kafka and Zookeeper, you have to learn it on their own. It doesn't come with the images from 2.0 because it's going to be deprecated. The Solo and Kafka will going to be deprecated from version 2.0. So that is why it is recommended to go with Raft. Whereas Kafka uses pools of servers, which is also called Kafka brokers, and the admin of the order organization specifies how many nodes they want to use on a particular channel, Raft allows the user to specify which ordering nodes will be deployed to which channel. Raft is the first step towards Fabric deployment of Byzantine fault tolerance ordering service. So we've learned about what Byzantine fault tolerance before. Please visit those lectures if you are unclear with it. So Raft is the first step towards solving this problem. So It is recommended that you go with Raft, and the implementation details of the Raft will be given to you or explained to you in the practical section. That is it for this lecture. In the next lecture, we are going to look into one more component, which is Fabric Certification Authority. See you in the next section.